This presentation provides an overview of Chapter 17 in the book titled Simple G, a gridded economic approach to analysis of sustainability of the Earth's land and water resources, edited by Aman Hakiki and Thomas Hurdle, and published by Springer. In this chapter, you'll learn about the interplay between a pandemic and environmental stressors, and we'll explore the global to local to global framework, which will help us understand how different systems interact with each other. You can apply similar approaches in evaluating other compound extremes, from human and environmental systems. This slide provides an overview of all chapters in the Simple G book, each of which has an accompanying presentation to motivate the material covered in that chapter. During this presentation, I'll cover Chapter 17, which is on the interplay between the pandemic and environmental stressors. Previous chapters laid the groundwork by providing theoretical foundations, introducing general conditions, specifying mathematical equations, discussing the gridded data and parameters, computer implementation, and validation. This chapter allows us to put all the theory into practice, using a unique framework that includes three models: Simple G, the Water Balance Model, and the Global Crop Water Model Emulator. During the COVID-19 pandemic, China implemented strict lockdowns that limited greenhouse gas emissions. These measures included travel restrictions, factory closures, and limitations on businesses, which resulted in a significant decrease in the burning of fossil fuels. It's essential to note, though, that these measures also had an impact on people's livelihoods and prices. Apart from the pandemic, environmental stressors such as drought can also impact food prices and economic activities. The question we're asking here is, what happens when pandemics and droughts occur together? Evaluating how pandemics and environmental stressors, like drought, interact isn't just about understanding one crisis at a time. By examining them together, we gain crucial insights into how these combined threats can magnify problems. However, this requires economic, hydrological, and agronomic evaluation at global and local scales. This knowledge is critical for building resilience and identifying vulnerabilities. To measure the impacts of a compound pandemic drought event, three global models have been coupled together. First, there's the Simple G model, which is a global economic model with spatially resolved decisions on land and water use. Then, we have the Water Balance model, which helps to project changes in water availability. Finally, there's the Global Crop Water Model Emulator, which is used to predict how crop yields will be impacted. The inputs to this system are daily climate variables, as well as the annual change in income due to pandemic. The outputs are GHG emissions from food system and food security outcomes. We've run this system for multiple years, but we'll focus on 2015 as the reporting year, since that's one for which we have the best database. The test experiment teaches us two important things. First, the biophysical models project highly heterogeneous impacts on yield and water availability. Second, the final outcome on the economy and food system will depend on how people respond to these changes, often termed the degree of adaptation. This means that economic responses, such as changes in trade, production patterns, and groundwater extraction, will play a crucial role. Without adapting to these changes, or with minimal economic responses, there'll be a significant reduction in GHG emissions, but at the cost of a larger, undernourished population. With market adjustments and adaptation, however, the negative effects can be moderated. If you're interested in learning more about the impacts of compound pandemic weather extreme, please review Chapter 17 in the Simple G book, where you'll learn how to design such a complex experiment, what the contributions of each adaptation channel are, and whether the interaction between these drivers is synergistic or antagonistic. Here, you'll find additional readings and references you might be interested in further exploring. On this slide, you'll find the link to the SimpleG webpage, where you can find additional resources, as well as links to the book and other chapter presentations. Lastly, we also gratefully acknowledge support from the U.S. Department of Energy, the Department of Agriculture, and the National Science Foundation. Thank you for watching this presentation on the SimpleG book, Chapter 17. We encourage you to explore the other companion videos that accompany the book on the SimpleG webpage.